Welcome to my channel. Today video lecture it is introduction about the data structure and algorithms. First we have to see about the definitions of an data structures. It is the foundations of the computer science and software development. It is organizing the data efficiently and solving the problems effectively. Generally, this data structure and algorithm is the foundation of the computer science and software development. It helps us to organize the data efficiently and design algorithms to solve the problems quickly and correctly. And the data structures generally be defined in the case of this group of data elements. It is a group of data elements which provides an efficient way of storing and organizing the data. So storing and organizing the data is very important over here in the definitions of a data structures. So data structures are the main part of the many computer science algorithms as they are enable the programmers to handle the data in an efficient way, and it also plays a vital role for enhancing the performance of the software, or it is a main function of the software to store and retrieve the data informations. So why we have to study this data structures and algorithms? So the first one, the data structure means it is a way of organizing, storing and managing the data so that it can be accessed and modified efficiently. Where this algorithm, the definition is, it is a finite sequence of well-defined steps used to solve the problem or perform the computations. So this DSA, that is data structure and algorithms together, generally combines the right data structures with the right algorithm to build efficient programs. So this data structures and algorithm means it is a combination of data structures plus algorithms to build an efficient program. Efficient program. So this is called as the efficiency and scalability of the program and the solutions for solving the problem, and it is majorly used for software development and it could be used for this placement preparations. So we have the next thing, it is called as a classifications of the data structures. So previously we have studied that efficiently. So efficiency means it reduces the execution time and memory usage. And scalability means it helps the programs handle large amounts of data. A problem solving means encourages a logical and analytical thinking. So next topic is a classification of a data structures. Where this classification of data structures, generally it should be defined by means of this primitive data structure and non-primitive. So primitive means generally this integer, float and character and boolean are called as a primitive data structures, data types. And the next one is non-primitive, means it is an array, linked list, stack, queue and tree and graph are the non-linear, non-primitive data structures, where this has also been represented by means of linear and non-linear. So linear means it is an array, linked list, stack and queue, and the non-linear means it is a tree, graph and heap are generally called as a non-linear data structures. So here majorly this data structure is represented by means of primitive and data structure non-primitive, and this primitive means it is a very basic data type which is called as a integer, real, character and boolean. Non-primitive data structure, it is an array, linked list, stack and queue. So non-linear data structure is trees and graphs. So generally this array means it stores the element in contiguous memory locations. So similar set of data type that should be represented by means of an array. So this is called as an array. And linked list means it is stores the elements as nodes, right? So it is nodes, elements as nodes, and that will be connected to the by pointers, by means of pointers. So this is called as a pointers, and this is the structure which represent that as a node, right? So this combination is generally called as a linked list combinations. And next one is a stack. So generally this stack which follows a first is a last in first out. Last in first out. So means that this could be in this like this structures. So the element going first that comes at the last, right? So or we can say it is a last in first out means what is the element which is last that should be comes first. So that is a structure for the stack. And next one is a queue which follows the first in first out. And next one is a nonlinear data structure which represent as a trees and graphs. So tree means it is a hierarchical structure with parent and child relationship. So which could be represented by means of parent and child relationship. And graph means it is represented a relationship between entities using the vertices and edges. So that should be represented by as G. It is V comma E. So V is called as a vertex and this E is called as a edges. So here in this linear data structures, it can be represented in memory into two different ways. One is called as a sequential memory and the next one is have to a linear relationship between the elements by means of sequential memory locations. And the other way you have the linear relationship between elements by means of the link representations. So this nonlinear data structure, if the elements of the data structure are not stored in a sequential order, means we can say it is a nonlinear data structures. So the relationship of adjacency is not maintained between the elements of a nonlinear data structures. So the example is trees and graphs are the nonlinear data structures. And these are all the common data structures: array, linked list, stack, queue, and tree and graph. Generally, we can say that algorithms means it has a input and it has output and definiteness and finiteness. So these are all the characteristics of this algorithms. Effectiveness are the characteristics of an algorithms. So this is considered for an algorithm which has to finding the maximum element in an array or whatever it may be. So we have to first assume the first element is maximum. Suppose if we have a n numbers, so that n that should be 3 numbers. Let me consider. This is 10 and this is 12 and this is 15. So I just want to find the maximum element in this array. So first assume this first element is maximum. So I have to check this as a fix as a maximum and compare the remaining elements. So I just compare this with next element. Suppose if that is maximum, then this pointer points to this next element. And so what it happens? It has to update the value of this maximum. So initially the maximum value is 10 and if you are checking with the second element, this is greater than this max. So it updates the value of max 12 and next it has to compare with this 15 and if you are comparing this 12 and 15, this 15 is maximum, so it updates the value of this max. So and finally what will be the value that should be stored in this max that should be represented. So this is called as a maximum of this given numbers. So this can be calculated and these are all the steps. It is algorithms means it is a step-by-step process. So it has to giving you the sentences which is called as an algorithms. And this is an important one in this data structure algorithm. It is an algorithm analysis. So when you are doing this algorithms, we just have two ways. One is called as a time complexity and the other one is called as a space complexity. So time complexity means it measures how the running time of an algorithm grows as compared with this input size. So this is input size. According to this input size, the running time of an algorithm it varies. So This is called as a time complexity. So the time complexity measures how the running time of an algorithm grows as the input size increases, right? And some certain period of time it should be going maximum, and again it has to fall on this minimum. So that happens in certain period of time. So space complexity, in the sense, it measures an amount of memory used by an algorithm during the program execution. So these are all the two measures of an algorithm analysis. So these are all some of the notations. So this could be called as a big O of 1. It is constant time. And this could be a logarithmic time of an algorithm, and this one is called as a linear time, and this could be the efficient, which is generally used for sorting or searching, and this could be a quadratic time. So these are all some big O notations used for finding this time complexity analysis. So these are all the real world applications. Generally, this Google search engines is the best example for this real world applications, and social networks, databases, operating systems, and navigation systems. So these are all the search engines. Means, for example, it should be mainly used for graphs and ranking up algorithms, and social networks means graphs for connections and recommendations. So it is something like a graphs could be majorly used. This could be majorly used for these two, and this databases, which could be used for this tree concept, or in some cases it has to using this hash tables. So this hash tables could be used for indexing, and this operating systems, we can go with this queue and scheduling algorithms. And this navigation systems, we can go with this graph algorithms, which could be used for finding the shortest path. This is a summary of this lecture. So the data structure, organizing the data and efficiently should organizing the data. Algorithms provide step-by-step solutions for the problems, and DSA, which improves the efficiency, means that it improves the program performance and scalability. And time complexity and space complexity are the two important techniques which is used for evaluating the performance. Means that time complexity and the space complexity are the key measures of the efficiency. And also we can see about this in this data structures, different kinds of the data structures which could be used over here. Thank you.